All right, guys, welcome to the Big Practice Sheets of Identities video. And I'm going to be going through every problem in detail. There actually might be more than one video based on how quickly I go. So if you had a problem with a specific one, please go directly to that one. I have taken the lock off so that you can go to whatever problem you need. So let's start with number 4. When I look at 4, order of operations tells me to look inside the parentheses first. So I ask myself if tangent x minus secant x can be combined in any way. Well, these aren't like terms, so that's a no. And then I ask myself if there's an identity. The only identities we are familiar with at this point is the sine squared plus cosine squared equals 0 or equals 1. So because neither of these are squared, I can't do that. So what I'm going to try then is the distributive property. So if I do that, I would get cosine of x times the tangent of x minus the cosine of x times the secant of x. And here is why I like what I see. I notice that I have two things in terms of cosine, and so I look at tangent and say, ooh, I can convert that to sine of x over cosine x, then that original cosine is still there, minus cosine of x, and the secant is really 1 over cosine of x. I doubly like this because the cosines over here cross out, the cosines over here cross out, so I'm left with just sine of x minus 1. Not like terms, nothing squared, we're done here. Number 5. This reminds me of the one we did in the previous video because these are not like terms, these are not like terms. I don't have a fractions, there's nothing about denominators, but I think I can take out a greatest common factor. So this one actually already had the greatest common factor taken out, and we multiplied it back in. This one, it makes more sense to take the GCF out. So if I look at what I have, this term has a cosine squared in it, and this term has a cosine to the 4th. So we can take out 2 of the cosines, or cosine squared, and we'd be left with sine squared of x, cosine squared divided by cosine squared is 1, plus, if I take 2 of them out of 4 of them, I am left with 2 of the cosines. So just like the warm-up problem, sine squared x plus cosine squared x is a Pythagorean identity that equals 1. So I'm multiplying cosine squared x times 1, which is why my answer is just cosine squared x. Number 6. Looks like I'm multiplying a binomial times a binomial. I cannot combine like terms in either binomial, so I'm thinking that we're going to have to do a double distributive property, aka FOIL. So let's do that, shall we? Multiply the first terms. I'm going to write it all out. Sine x times sine of x. Next one we're distributing, plus sine of x times cosine of x. Then distributing the negative cosine, so that's minus cosine x times sine of x. And then I'm going to run into this problem a little bit, but that's okay. Negative cosine x times positive cosine x is negative cosine x times another one. So if I look at what I have, let me simplify. Sine of x times another sine of x is sine squared x plus sine x cosine x minus another sine x cosine x. Yes, you can switch the order when you multiply. It doesn't matter what order you multiply. And then you're subtracting cosine squared of x. Now, these two terms here are like terms, one positive and one negative. So these two cross out. So you're just left with sine squared x minus cosine squared x. Now this is what I was talking about, and please don't mind my scrolling for a minute. This is what I was talking about at the end of the last video, that this is not quite the Pythagorean identity because this is subtracting and this is adding. So it doesn't equal 1, but what we can do is manipulate it so it looks like the answer that's on your key. And the answer that we have on the answer key is 1 minus 2 cosine squared of x. So this is what we want, and this is what we have. So notice, what we want only has cosines. So I need to replace sine with something. So again, if you don't mind my scrolling, I'm going to go back to this. And remember that cosine squared is equal to 1 minus sine squared from here. And sine squared is equal to 1 minus cosine squared from here if we manipulate this. So if I want everything in terms of cosine, I'm going to replace sine squared x with 1 minus cosine squared x, and then I have the other minus cosine squared x. If I get rid of the parentheses, I guess I don't technically need them there. If I get rid of those, if I combine like terms, I would get these two being combined to a negative 2 cosine squared x, which is where, or why, this could be one form of a final answer. The reason we don't leave our answer like this is because we usually want to get one trig function if possible. Number 7. I again look inside the parentheses, order of operations, and ask, can I combine a cosine with a cosecant? Well, again, those are not like terms. So let me distribute the tangent y in just to see if that gets me somewhere. Sometimes it's good just to try things. So we have tangent of y times cosine of y minus tangent of y times the cosecant of y. Well, I like sine, cosine, and tangent a little better than other things, but let me again just kind of play around and see if I can get anything to cancel out. This tangent of y could be replaced with sine of y over cosine of y. Now, I like that because I notice I'm going to multiply by another cosine, and that's going to get things to cancel. Let me take this tangent of y and also change it to sine and cosines. Sometimes it's a really good idea to replace tangents with sines and cosines just so you can see something better. This cosecant, let's replace that with 1 over sine because now on this side, the cosines cross out minus the sines cross out. So here we're left with sine of y minus 1 over cosine of y. There's really the 1 in the numerator. Again, leaving an answer as a fraction is not that ideal. So instead, let's write this final answer as sine of y minus the reciprocal of 1 over cosine, or this is really equivalent to the secant of y. Not like terms, we're done. Number 8. Again, can't combine anything inside the parentheses, so let's go ahead and distribute this in and again just see if it helps us at all. So we have cosine y sine y times secant of y plus cosine y sine y times cosecant of y. This problem reminds me a little bit of the one we just did. So let's see. Cosine I like, sine I like. So let's replace that with 1 over cosine of y. And that is going to be very helpful because this cosine and that one are going to cross out eventually. Cosine I like, sine I like. This one, let's change to something more recognizable. Cosine of y, sine of y times 1 over sine of y. So in this first term, the cosines, one's top, one's on bottom. In the second term, the sine, one's on top, one's on bottom. So here I'm just left with sine y times 1, which is just sine of y, plus cosine of y. Now, this does not say sine squared plus cosine squared, so the answer cannot be 1, but the answer can be left like this because I cannot combine anymore. Number 9. Now this one is a very common mistake. A lot of students look at this and say, oh, both the sine b and the negative cosine b should be squared. Yes, but please don't forget that this is really written as sine of the angle b minus cosine of that angle. And the definition of squared means it's the same parenthesis twice. So this actually ends up being the distributive property twice, or AKA, well known as FOIL. So please don't fall for that. Please remember or write yourself a note that this is FOIL, or the distributive property, and it's not just raising things to the second. So let's go through this again. I might run out of some space, so bear with me. If I multiply these two, we have sine, let me just save a little time here. If we multiply sine of beta times sine of beta, that's sine squared beta. If I multiply sine beta times negative cosine beta, that's negative sine beta cosine beta. I said b before, but technically this is a beta. If I multiply these two, that's another negative sine beta cosine beta. And then finally, a negative cosine beta times another negative cosine, negative times negative, gives me a positive cosine squared beta. So please be careful here. These two middle terms do not cross out because we have a negative something combined with another negative something. So there are two of these negative somethings. So you really have sine squared beta minus 2 sine beta cosine beta, because there's two of them, plus cosine squared beta. What I do notice, though, which is again quite handy, is I do have sine squared of b plus cosine squared of b. And this is, excuse my moving around again, this is the Pythagorean identity, sine squared plus cosine squared. Sine squared plus cosine squared. So these two together do equal 1, but then I still have minus 2 sine beta cosine beta, which is why this is my final answer. Okay, probably have time for at least one more, maybe two in this video. Feel free to rewatch any example you'd like. Number 10, again, looks like it's a FOIL to me, or a distributive property twice. So let's see where this takes us. You're going to notice some of them have common themes. We have 1 plus sine t minus sine t minus sine squared t. This time, my two middle terms do cross out because they are one term minus the same term. So I'm left with 1 minus sine squared t, which amazingly enough can be simplified because back to that Pythagorean identity, sine squared x plus cosine squared x equals 1. So if you notice, if you subtract the sine squared x over, cosine squared x is equal to 1 minus sine squared x. And how convenient. We have a 1 minus sine squared of an angle here. So this could be completely replaced with that. So my answer is just cosine squared of t. And if this was not on the answer key, feel free to change it on your answer key. I would say that the green is a much better simplified answer than the blue because of this Pythagorean identity. Last one for this video, number 11. When I look at what I have here, again, I don't have any like terms, but I do look like I have some cosines in common. So I have 1 cosine here and 2 here. So I can take 1 greatest common factor of cosine out, and if I do, I'm left with sine x plus cosine x. And I look at what I'm left with, and I say to myself, these aren't like terms. This is not the Pythagorean identity. So unusually, we're done here. There's nothing else you can do but take out the cosine of x, and that's it. All right, guys, so on the next video, I will be doing numbers 12, 13, 14, 15, and 16. So please join me there if you need help on those. Thank you.